Hey everybody, thanks for joining today. Again, I'm Matt Jennings, product manager for Cambium Networks here at Streakwave. We're going to be talking about something a little different today, and I hope that you perk up and listen up, because I think what Steve is going to share is really going to be valuable for your network, and it's something that I think it's one of the last things people think about. And this product that they have come up with, I think, will be invaluable to anyone with a Cambium network. And even if you don't have a Cambium network, QoE is something that you guys can really use. So I won't spoil the fun and what's going to happen. So Steve, if you wouldn't mind, take it away.
Sure, yeah, thanks, Matt. So I'm Steve Kielley, Regional Sales Director for Cambium and North America Business Development Director for QoE specifically. So I've been promoting QoE for several months now, and I've learned a lot from our WISC community. And I have to say that after selling for Cambium for 8 years, different products that we have from point to multipoint and backhaul and Wi-Fi, this is the one product that is really fun to sell because it's actually universal, like you said, Matt. It works on any brand of product out there. It's not proprietary to Cambium. And it affects the entire network. It's not just the access points or the SMs. It's backhaul, it's everything from the IP address all the way back to the NOC. And it also is beneficial to all different types of media. It's not just wireless, it's also fiber and cable as well. So to jump right into it, I'm going to be talking about several different of the feature sets. And I just want to kind of go through them here just to talk about the highlights, and then I'll take a deeper dive. But some of the things that our QoE does that's specific and unique is the TCP Optimizer. And it basically sits, it's a proxy, and it sits, our QoE box sits in between the NOC and the network, the internet and the network, and it intelligently manages the acknowledgements. And like I said, I'll go a little deeper into that. And it actually accelerates the traffic. Then we give a multitude of different network visibility statistics that give you insight into your network, and then allows you to write certain traffic shaping rules or do different rules to reduce latency and control the different TCP traffic. And then we also have our traffic shaping multi-queuing. And so we're actually able to prioritize the different types of traffic, whether it's interactive or it's bulk downloads or maybe streaming. And then another thing that's very specific to us is that we do this speed test detection, and I'll talk about that a little bit more. Another feature that some of our competitors offer, but they're very expensive and it's a subscription based, is the auto congestion detection and management, which helps balance the throughput and the latency in the network. And then finally, because we are a DPI-based QoE, we can actually tell you down to the IP address, where a DDoS attack may be sent from. We can't actually stop them, but we can at least detect them, identify them, and then you can go to work to stop them. And then finally, we're a manufacturer of wireless products, and so we understand, spectrum, we understand channel planning, we understand MIMO. And so a lot of the way the hardware works, the radios, how they send their acknowledgement, it's an intelligence that we can actually pack into our QoE to help optimize the wireless hardware. So there's two different deployment models. The one that we are focused on is the one on the right. And so this is what I said, where you have a server and it sits between the internet and your network, and all your traffic goes through that server. And it allows us to accelerate the traffic. It allows us to shape different applications and prioritize different applications to the entire. The model on the left is just a hardened 1 gig box, and it's basically a tower model. So it allows us to tell clients that they want to dip their toe in the water. Here, let's just try it on a specific tower, perhaps a tower that you're having a lot of congestion with. And we can put the QoE box on that tower and let them see what it can do on a tower basis if they don't want to go all in on the NOC model and try that. So let's talk about the TCP Optimizer. This is probably the one most important feature that we've got, the one feature that it can accelerate traffic across your entire network. And as I said, it's the QoE box sits between the internet and your network, and it acts as a TCP proxy. And it's going to intelligently manage the acknowledgements as opposed to just having a dumb pipe where for every TCP packet that's sent, there's an acknowledgement sent. So I've got and as you know, with TCP traffic, what ends up happening is as you get congestion and you drop packets, then your throughput drops aggressively. And so you end up having these big spikes in your traffic where you'll be going along really well, delivering a bunch of bits, and then all of a sudden you get some congestion and drop a packet, and it'll drop the throughput dramatically, and then it starts to ramp up again, then it drops. This little video I have is a really good illustration, makes it much easier for me to explain how this works. But essentially on the right hand of the screen, we're going to be sending 3 rounds of packets, the first packet, and then 2 packets, and then 4 through 7 is the 3rd round of packets. And we've got the internet on the right, or data center, and then the client on the left. And both paths are 5 seconds. This is an actual test. We just put it in a visual basic explanation. But the QoE box down here on the bottom sits in between the path. And so it's going to act as that proxy, and we start our download. And so you can see that the first packet sent, and the QoE box has already received the packet and is in the process of sending the acknowledgement back to the data center. Whereas on the top, the first packet is still in transit, hasn't been received, and it hasn't sent its acknowledgement yet. Now the QoE box got packets 2 and 3. It said acknowledgements for packets 2 and 3 and says send the 3rd round 4 through 7. And all the time on the left between the QoE and the client, it's managing the acknowledgements there to make sure there's no drop packets. So it's now saying send all the packets 4 through 7. It's completed in 17 seconds, whereas the dumb pipe at the top is still working, and now it's completed in 25 seconds. So that's how TCP acceleration works. And if you do the math, that's an 8-second increase in speed. You divide that by 25 seconds, and you got a 32% increase in delivering those packets. And so a lot of people will say it increases capacity when you add a QoE to your network, but really this TCPO is different. It's actually accelerating the packets, getting them routed to the client and off of the network, so it frees up the network to do other deliver more packets. So we did a test case just to kind of show this. You've got the internet, you got the QoE box, and we got our EPMP 3K AP. We introduced artificial noise between the EPMP 3K SM and the AP, and we ran a Netflix application, and we ran a Netflix video debug with statistics so we could see the actual bytes, and then we could actually graph them. So when you look at the graph that we came up with, you've got at the bottom, you can see the legend, and it says bit rate without TCP Optimizer, where you can see that you start to introduce congestion or interference, and you start to drop packets, and the TCP protocol does what it's supposed to do. It aggressively ramps down, and then it starts to ramp back up, and then it aggressively ramps down, starts to ramp back up again, and so on. When we turn the bit rate, the TCP Optimizer on, you can see that the bit rate stays at a high level, and then it manages the acknowledgements and then at a high level. So you're going to deliver more bits across the network with TCPO on versus off. So as I spoke about earlier, you've got different types of networks with different types of media, and how does QoE affect that, or specifically how does TCPO affect that? So we've got the different WISPs, we've got LTE, we've got fiber, and we've got cable. And as you can see, that the TCPO actually benefits all of them. The gray bars with TCPO off and the red bars with TCPO on. So we actually send packets across the network with TCPO off, and then we turn it on and send packets with TCPO on across these different media, across the different protocols, and you will see an increase because we're intelligently managing those acknowledgements on behalf of the network. What does that mean to the clients at the end? Your end customers that you're serving broadband to? Well, it means that their page loading times are going to be faster. So they're going to actually experience a better quality of experience when they load applications like Amazon. You can see that with the accelerator off, it takes 22% longer than with the accelerator on. Moving into the next feature is the network visibility. So as I mentioned, we're DPI based. Some of our competitors do not use DPI, it's FQ Codel. And so with the FQ Codel, it's basically looking at certain aspects of the packets and how they're transmitted. And it's saying that you look like your interactive traffic, so we're gonna put you in this queue. You look like your streaming traffic, we're gonna put you in this queue. And all other traffic, we're going to just call bulk traffic, and we're going to put you in this queue. But with DPI, we actually can see inside the packet, and we can identify the actual packet itself, and we know exactly what that packet is, whether it's a Netflix flow, or if it's a Netflix 4K flow, or if it's a Zoom meeting. So what kind of statistics can we give you? Well, network-wide, we can show you a graph with the throughput on the side and the time across the bottom. We can actually show you which applications are being used and how much throughput they use and exactly what time. So network-wide, you can start to see that these are the times in my network when peak traffic is, and most folks know that, but you don't know what applications are causing that peak throughput. With the DPI-based QoE, you can actually see which ones they are. And at those times during the, and we'll talk about this in the multi-queuing a little bit more, but at those times, there's certain applications that don't need priority. So if you're going to have, your Netflix streaming at 4:30, 5 o'clock at night, people are starting to come home and want to be entertained. Maybe somebody gets onto an Xbox and they decide that they're going to do a big download, and it's a 61 gig download of some game. And these gaming applications tend to be very aggressive in their use of the bandwidth. So what we're able to do, because now we know what kind of traffic and what applications are being used across the network and at what time, we're actually able to start to write some rules around those applications and decide which ones have higher priority and which ones are going to get the different bandwidth. We can do some bandwidth shaping. So, and we can do this at a subscriber level, of course. We can show when the applications are being used and how much bandwidth they're being used, so we can actually shape all the way down to the subscriber level. And then you can get all your different subscribers, and this is very useful information. You can show every subscriber on your network and what applications are being used, so you can develop insights like this, where you can see that this is the peak of the network and all the different subscribers. And then inside that peak, which ones are actually using the most amount of bandwidth. And we're actually able to capture retransmits and also latency. And we can see your sort from highest to lowest in your retransmits. And so what that allows us to do is it identifies the different SMs that are out there that are having some sort of issue. It may be that a tree grew up in the way of the SM and is starting to cause some problems. Maybe there's a new noise source that has developed, or maybe the wind has blown the SM off of alignment and it's on a side lobe. But by getting these this list of highest to lowest number of retransmits, it actually gives your support tech people a list of different SMs that are the problem. And as we all know, that if you go out and you fix the problem and you get these SMs to perform better, then the AP capacity goes up and the network is healthier and everybody's happier. So some of the statistics that we can see at the subscriber level, we can see the actual peak throughput of the subscriber. Sorry, just goofed up my screen here. Little technical difficulties here. Okay. And then we can see the max speeds. We can see the latency over time. As I said earlier, we can see the transmissions, and then we actually see active and creative flows as well. Going into the MultiQ Trafficshaping, what we can do is, because we've got DPI, we can actually identify the different applications, and we can put those applications into an unlimited number of queues, and we can actually shape the different flows in the different applications. All the way down to the subscriber level, you can make it as complicated as you want, or you can make it as simple as you want. You can write some really basic rules to basically say that, hey, you're all interactive traffic. This is a GoToWebinar or a Zoom call, and we're going to make you the highest priority. Or and then the next would be streaming, and then the next would be bulk. And you can just do really simple rules like that across the entire network. It doesn't have to get too detailed, or you can actually start to do individual rules at different times of the day based on actual applications like BitTorrent, and you can rate limit BitTorrent at anywhere from 4 to 10 o'clock at night. And what you'll see is that when you've got this single queue over here on the left, you'll have a Zoom packet that's stuck behind some Netflix packets, and whoever's trying to have that Zoom call, they're going to have a bad experience. You're going to have some breaking up of the voice and the buffering of the video until that Zoom packet can get sent through. But what we do is that we have the queue at the top for higher priority, more sensitive traffic, like the interactive traffic that we're on right now, with a GoToWebinar call. And then you can have your Netflix traffic down here in a secondary priority queue. And when you have that, you have this big decrease in latency, 20%. We have graphs in our QoE and our GUI that we can show you this. And it's not just something that we say happens. We can actually graph it out and prove that it's happening. So here's a little video again to show you that when you have a limited queue, you've got these YouTube packets flowing in, and here comes a Netflix packet that's stuck behind it. Down here, we've got these equal queues. They don't have to necessarily be higher priority or lower priority. And we're going to serve these packets in a round robin to ensure that they don't have any issues. But all of a sudden, you have this Zoom call that comes through, and it can go right on through. Whereas this packet up here with this Zoom call is now buffering and is stuck in this single queue. And as I said, you can have as many queues as you want and put them in different priorities, and you can even change the different time that you'll have the priorities in different rules. So once again, we set up a test just to prove this all out, and we have the QoE box sitting between the internet and the client, and we're going to have a 10x5 package, and then we're going to do simultaneously downloads of different applications. World of Warship, which is a popular war game. It's like a tank game. And then we're going to start 2 YouTube videos, and we're going to open Facebook, and without QoE, and then with some basic rules. So what you'll see is that the gaming application is extremely aggressive in its download, and it's taking up 89% of the capacity. And down here, YouTube, which is interactive or streaming traffic, it's having issues because it's at 0.11% of the pipe. The gaming application, the download, is actually consuming too much capacity, and you're having quality of experience issues. Your customer is not going to be happy. So we write some basic rules. We turn on TCPO, and we turn on the uplink and the downlink shaping. And we're going to have Wargame at the top, and we're going to limit the amount of throughput that Wargaming can have, and then all other applications will be on the top. And then we rerun the test, and you can see that now Wargaming has been limited to 1.64 megs, 21% of the pipe, and YouTube is up and healthy at 78%, not buffering, and they're having a quality experience. So we're talking with a lot of WISPs about this, and we're talking with a lot of people that are running other competitive products, and they're saying that, yes, we're starting to identify how people use traffic. And this is exactly what happens, is that people come home, somebody wants to do a download, and what do they do after they start their download? They go straight to some sort of entertainment like Netflix, and they watch a movie while their download completes. So it's kind of a double whammy on your network. And the QoE box gives you the ability to control that, so you don't get a lot of support calls and people complaining about your service.